back to Easy High School Physiology. I'm Dave, and this is Module 14. We're going to start the nervous system. Now, I've got to tell you that it took some time for me to get this together because the nervous system is quite complicated, it's quite complex. Even when you look at something like the heart, such an interesting module, the only thing that the heart does is pump blood. That's all it does, pump blood. Does a good job of it, but that's kind of a one-track deal. Where the nervous system just is into every part of our body. The nervous system, by the way, doesn't mean a system that's nervous, like anxious. It just means that it's made up of nerves. And the major part of the nerves, of course, is the brain. And we're going to start taking a look at the brain today. I've divided this topic of the nervous system into 3 parts. Today we're going to go over what I call the outer part of the brain. Much of it is voluntary and is actually, you can see it from the outside. The second part of the course of the module, we're going to go deeper inside the brain to parts of the brain that have to do with keeping you alive and with your emotions. And the third part of the nervous system, we'll get into the nerves themselves, the neurons, the nerve cells that comprise the nerves, how nerves send messages, and various things like that. That will be the third part of the topic. So today, what I'd like to start out with, I'm going to take this away now, and I'd like to give you kind of a concept of the nervous system, and I'm going to use the analogy or the comparison of a ship. Let's call this a passenger ship. It's one of those large ships that go across the oceans, and of course there's a captain. All right, and the captain is in charge of the ship, but the captain can't do everything by himself. The captain must have information about what's happening so that he can decide what to do. Now, here's his crew over here, all right, and his crew, their job is to give him information. Their job is to tell him how fast the boat is going, what direction it's going in, what the temperature of the ocean is, if there's any icebergs they're going to run into, how the passengers are doing, whether it's time to feed the passengers their food. All of this information the captain needs to know, and the crew will give him that information, all right? Now, once the captain has this information, he's going to decide what actions to take, and he's going to give commands or instructions to other parts of his crew to carry out those commands. Turn the boat this way. Speed up the boat this way. Slow down a little bit. Watch out for that iceberg over there. All those commands will come from the captain. So the captain obviously is the brain. And the crew over here giving him information is the senses that we've talked about before and we will continue to talk about. And this part of the crew over here that carries out the actions, these will be the muscles and the glands of the body that actually do the actions. Let's take away this idea here and show a little bit more specific comparison here. So here's the brain, it's the captain of the ship, and the brain needs to know what's going on. It needs to know what's going on both outside the body, those senses like seeing and hearing and tasting and touching, and it needs to know what's going on inside the body, like blood pressure and body temperature and heartbeat. And all that information goes to the brain via nerves, okay? When the brain figures out what's going on, it will give instructions out to the muscles and the glands. The muscles obviously have to do with movement, which includes not only walking around, but speaking and gesturing and sleeping and waking up and going to work and every way that muscles can possibly work. Glands have to do with secreting hormones. The hormones affect our emotions quite a bit. And we're going to get into that in the second part of the topic. Okay. So, what are the abilities of the brain or the nervous system? I'm going to list some of these, and normally what I do is write them out myself with a pen, but there were quite a few, so I decided to type them out here. And let's look at the various abilities of the brain or the nervous system and what makes it so complex. So the nervous system or the brain has to do with thinking, planning, problem solving, deciding, learning, memory, imagination, motivation, movement, balance, coordination. Gee, that must be all of the abilities, right? Sorry, wrong. There's more. Look at this. Awareness, concentration, heartbeat, breathing, blood pressure, body temperature, hunger, thirst, sex, and sleep. And I don't even know if I got all of them, but that's enough to give you an idea of all the activities the nervous system is responsible for. And we're going to start our view of the nervous system by looking at the brain. This is an actual photograph of the brain. We're only taking a look at part of it we're looking at the side of the brain. This is the right side of the brain as seen from the left side. Okay, so here's the front here, and here's the back over here. All right. So we're going to start out looking at the outer part of the brain, this part right out here, including this little part right there. Okay. And in our next time we have a module, we're going to take a look at the very inside of the brain right here that has more to do with keeping us alive and our emotions and so on. But we're going to start on the outside of the brain. Notice, just like the small intestines, the brain has all these kind of coiled up squiggles here, and as you might guess, that is to increase the surface area of the brain, of the outer brain here. Okay. It's kind of hard to tell things from a picture like this, so we're going to look at a little bit more of a diagram here. And here what we see, this time the front of the brain here, back of the brain here. All right. Here we're going to call this the outer part of the brain. This is the inner part of the brain here. This is where we're going to call the brain stem. This is something called the cerebellum, where it has to do with balance and coordination. Okay. All of this is contained in the cranium, or the skull, the bony part that protects the brain. And now we're going to move to look at the different parts of the brain. These are the parts we're going to take a look at. I'd like to go over the vocabulary with you. Again, along with what I'm trying to do in this course is limit the number of technical terms, but there are some that we need to take a look at. We're going to be looking at what's called the frontal lobe. Lobe is just a big part of the brain. We'll also be looking at the parietal lobe, parietal. Also at the occipital lobe and the temporal lobe. There are 4 lobes. These are the big 4. But we're also going to be taking a look at the cerebellum and the brainstem. Okay, so there's the vocabulary. Now let's take a look at the picture now and see if we can assign a description to each part of the brain. Okay, here's our picture of the brain. This is the front, this is the back. Okay, it's not really colored this way. They're just doing that to make it easy to remember. This is the frontal lobe here, all right? It makes sense because it's sort of in the front part of the brain. If you take your hand and put it on your forehead, you're pretty much putting your hand right here in the frontal part of the brain. The frontal lobe is where we do higher order things like thinking, planning, deciding, pondering, imagination. All those kinds of things happen in the frontal lobe, all right? We're going to jump all the way to the back here because it's just a very simple description. The very back of the brain, and we mentioned this before when we went over the eye, has to do with vision. Anything that we see with our eyes is sent by nerves to the very back of the brain here called the occipital lobe. And once that information is received, further information is sent by nerves to other parts of the brain in order to interpret what has been seen. Okay. Next, we're going to go to this side part of the brain called the temporal lobe. By the way, on the other side, you can tell this is the left side of the brain. The other side of the brain will also have a temporal lobe. It'll be obviously the right temporal lobe. The temporal lobe is concerned with hearing and with some memory, and right in this area right here with smell. Okay? And finally, we have on the top part of the brain right here is called the parietal lobe. And the parietal lobe has two main functions. One thing is this strip right here has to do with sensation. So anything that your body is sensing, mainly through your skin, through your organs inside of your body, anything like that, actually anything you see or hear or touch, is going to come up to this area of the brain to be interpreted, to make sense out of what that sensation is. All right. Just in front of the sensory area is something called the motor area, and as you might guess by the word motor, it has to do with action. And so when the brain has decided what the incoming sensations are all about, it sends messages out through the motor area, down through nerves, sometimes down the spinal cord to various parts of the body, telling the body what actions to take. All right. So that's the parietal lobe up here. So again, we've got the frontal lobe, the occipital lobe, the temporal lobe, and the parietal lobe. Okay. One more thing, as long as we're on the left side of the brain, there are two speech centers in the brain, both on the left side. One of the centers is right here. I'm not going to go over the name right now, but this is the part that hears speech and gives you, shows you reading, that you are, like you're reading a book or something like that. And it's those things that come in about words. This center right here has to do with speaking, so that when you're actually voicing something by speaking, that center of nerves is right here. So this one sort of interprets speech, and this one gives out speech, and it's all in the left side of the brain. Now, this thing sticking out here at the base of the brain, in the back of the brain, this is the cerebellum. And it has to do with balance and coordination. So it's very important to athletes in sports. As you might guess, this is part of the brain is connected to the semicircular canals that we discussed when we went over hearing and at the hearing module. So if this is damaged, obviously you're going to have a hard time coordinating your movements. This right here leads down to the spinal cord. It's the very top of the spinal cord. And we're not going to talk about the spinal cord today, but we will in our next module. Okay. You know, one of the external senses that I listed, but I didn't have a time to go over with you, was something called location. And I'd like to do that now. Okay? What I'd like you to do is do a little experiment for me. I'd like you to take one of your hands and put it behind your head. But don't touch your head. Just hold your hand behind your head. Everybody doing that? Okay. Now wiggle one of those fingers. Any finger, it doesn't matter. Just wiggle the finger. Okay? Now, here's the question. How do you know that you're wiggling that finger if you can't see it? Okay? Well, that's the sense of location. And here's how it works. If we look at our structure of our body here, we will see that we have various joints. There are joints in the feet, joints at the knee, joints in the hip, at the elbow, the hand, and so on, at the neck. Everywhere where there's a joint, there will be a group of nerves. And any time that that joint moves, those nerves will send a message up to the brain, telling the brain where that joint is, what it's doing. All right. The fancy name for this, and one reason I didn't go over it with you before, is called proprioception. Okay. So again, this is the way that your brain knows what your arms and your legs and your feet and your hands are doing in space without looking at them. Okay. Because they get messages from the joints. All right, proprioception. All right, there we go. So I got that out of the way. With that, I've covered all of the external senses. Okay, good. Okay, so we have said that the brain is divided into the left and right hemispheres, and I also mentioned that there was a connection between the two hemispheres. I just want to highlight this at this point. You see this structure right here. This is the only structure that actually connects the right hemisphere, which is this one that we're looking at, with the left hemisphere, which is not in the picture. This is called the corpus callosum. Corpus callosum, and if you can zero in on the spelling right there, corpus callosum, there it is right there. So what we're going to do next is look at the brain from the top, looking down, and I'm going to show you something very interesting about the brain. Okay, so we're going to look at this picture right here. We're looking down at the top of the brain. If we could go between the two hemispheres here, we could see the corpus callosum, but that's out of the picture right now. This is the front of the brain, and this is the back of the brain. All right. So as we've seen before, when we spoke about the parietal lobe, we said that the front part of the parietal lobe had a motor area, which we see here in red, which of course is not really red. And this is the area that sends messages down for the muscles to contract or some kind of movement. That's why it's called motor. And then the tract behind the motor area is the sensory area. So anything coming from below the lower part of the body, or even parts of the head, would go to this sensory area. It would be sent as a sense, as something to be interpreted as to what's going on. And it's this part of the parietal lobe that we're going to take a look at right now. Now, what scientists have done have actually taken people into an operating room and opened up their cranium or their skull and exposed the brain like this. And then while the patient was still conscious, the doctor or scientist would actually take a little probe like this and touch parts of the brain, starting from inside where the corpus callosum is, and then going down the side of it like this. And they would do it for the sensory and for the motor. And when they did this, they found something very interesting. And I'm going to show you, starting over here in the sensory area first. I'm going to bring this down right here. This is the left hemisphere. This is the corpus callosum here, all right? The right hemisphere we're not looking at. But what the scientists found out is if they went down different parts of the brain here in the sensory area and touched them with a probe, interesting things would happen. For example, if you touch this area right here, then the foot and the feet would actually feel something. The patient would feel that in their feet. And if you touch this area right in here, the patient would feel something in their hands and their fingers. And if you touch this area right here of the brain, the patient would feel something in their lips. Now, this is the sensory area that we looked at before on top of the brain. Now, the same thing would happen when the scientists went down the motor area. Here again is the corpus callosum. We do not see the other part of the brain here. And if we start inside and start again probing different parts of the brain, look what we find. If the scientist probes this part of the brain, well, the fingers and the hands start moving. It's not just that they feel something, but there's actually movement. And if the scientist probes this, there's actually movement in the nose and the lips and the face. And if the scientist probes this area right over here, then the foot and the toes actually move. So scientists have been able to actually map different parts of the brain like this in many ways. Not always. There's still a lot of gray area in the brain, but at least I wanted to bring this to your attention, that if you look at the different hemispheres of the brain and probe those areas, you can actually locate different abilities in the brain. All right? Very good. The next thing I'd like to get into is the protections of the brain. There are various ways that the brain is protected. And one of them is the cranium. All right? Now, I need to find the picture that will show that the best. Let's see, where was that? Right here. Yeah. Here's the cranium. Is the outer bony part of the skull. And of course, this protects the soft brain against any kind of injury. All right. There's also a disadvantage, and that is if there's any bleeding into the brain or any swelling of the brain, there's nowhere for the brain to expand. Now think about it. If you get injured in your arm or your leg or your foot or your hand and it swells, the skin can expand and take up that swelling. Unfortunately, the cranium is quite fixed, and if there is any swelling or bleeding into the brain, there's nowhere for it to go, and it exerts pressure on all of the parts of the brain. So they can be very dangerous. Sometimes during an operation, the doctor can actually make a hole through the skull hair into the high pressure area and allow that blood or that swelling to escape and relieve the pressure on the brain. Anyway, most of the time, our cranium protects us rather than makes us provides a problem for us. Another protection of the brain is called the meninges. Now, if we look just under the skull, here, we will find some very delicate coverings, which also protect the brain. These are called the meninges, and there's 3 layers of them. They're very soft and they're very delicate, and they also help to cushion the brain against any kind of injury. The meninges, when they get infected, can cause meningitis. So that's where meningitis comes for. For example, if there's a bacterial infection of the meninges, that will be meningitis. Okay. The third protection of the brain is called cerebrospinal fluid. Now, the brain and the spinal cord actually float in a fluid. The fluid has the consistency of plasma in the blood. It's a clear fluid, and there's about 150 milliliters of it throughout the brain and the spinal cord. So the brain actually floats in it, and the idea is to protect the brain from any kind of jostling or trauma. Like in boxing, for example, would be a very, very good example. So, go back to the brain again. Much of the fluid in the brain is in some hollow spaces, which we haven't seen yet, but it's up here. Some of the fluid is up here around the meninges, and some of the fluid is in the spinal cord, all right? And this fluid is replaced every day, so it's not the same fluid day to day. But the cerebrospinal fluid does protect the brain and the spinal cord from minor injury. Okay, so those are protections that we can see of the brain. I'm going to keep this picture here, but I'm going to give you 2 interesting stories or descriptions. And I'd like you to just kind of close your eyes right now and listen, because I'm going to show you a part of the brain that also protects us, but it does it in a different way. Now, I want you to pretend that you're at a party, and there's music, and there's dancing, and some people are drinking, and they're feeling very nice, very fine, and there's quite a bit of noise going on, and quite a bit of running around, and yet over in the corner there are 2 guys who are playing chess. They've just decided not to join in the party, and they're playing a game of chess, and they're completely concentrating on their game. And the question is, how is it that they cannot be disturbed by this party and play this game of chess? All right. Now, here's the second story. The second story is of a mother who's got a baby who's about 3 or 4 months old. And babies at that age like to cry a lot. So the mother is up with the baby quite a bit. And when the baby finally stops crying, the mother puts the baby to bed, and she herself jumps into bed and goes out like a light, right? Okay, so outside her window, there's traffic going by, people honking their horns, people screeching, kids running up and down making noise, an airplane flying overhead. All of this noise does not disturb this mother. Yet, when she hears in the other room, wah, 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 the mother jumps right up and tends to her baby. All right? Now, what is the thing that connects the two chess players and the mother able to sleep? Okay? And it's something called the reticular activating system. It's deep in the brain, and which is we're going to go to in our next module. It's called the RAS, the reticular activating system. It is designed to protect us from overload of stimulation. So it's like a filter, and it basically filters out about 99% of all of the stimulation or information that comes into our brain. It actually protects us so that we don't get overloaded. And it's this RAS which allows those two chess players at the loud, noisy party to concentrate on their game, and it allows the mother to sleep quietly with all the noise going on, because her brain will filter out the traffic noise and so on, but will not filter out her baby crying in the next room. All right? So this is a very important part of our brain, and I just wanted to bring it up. I think in our next module, I'll be able to point to where it is, but not today. I'm going to wrap up our introduction to the nervous system and brain with going over what the next module is going to go into more, which is the inside part of the brain. And that part of the brain has to do with keeping us alive, like heartbeat and blood pressure and body temperature, but also our emotions. And I'd like to go over the emotions that you probably have thought about, but maybe not recently. These are the emotions that we experience, and that we're going to take a look at how the brain, where in the brain these emotions come from. Love, affection, joy. What is that? Can't read it. I'm sorry, this is all upside down. Surprise, happiness, satisfaction, serenity. Okay, these we might call positive emotions, okay? And they are definitely part of what the brain can do. But unfortunately, we also have some negative emotions. Let's look at these. Fear, anxiety, depression, anger, frustration, sadness, shame, embarrassment, disgust. All right. So we could call these negative emotions, and of course, they all have a place in the brain. All right. So we're going to close out our introduction to the nervous system and brain today. I'd like to remind you that the next module, we will go deeper inside the brain. And in our third module about the nervous system, we will talk more about the nerves themselves, the nerve cells, how they transmit information, the electrical part of the nervous system, and so on. So I hope to see you in those modules also, and until then, I will bid you goodbye.